Why should we be doing maths? Kepler. How do I get the most oranges in the box? Directly on top or in the dimples of the first layer. 300 years later. Still no proof. Fancy hat wearing man Hilbert. Yeah, we really should get to solving that 100 years later. Tom Hale managed to do it. He proved it. Marina Viazovska came along and said, oh, that's really cute, but could you do it in 8 dimensions? Well done, mathematicians. Why though? Because of that silly little puzzle to do with the oranges to get proof in 8 dimensions, we now have better telecommunications with space. Kepler was alive in 1611. There is no way he could have imagined that his puzzle could possibly have been used for telecommunications with space. That is my #1 favourite thing about maths. Pure maths solves problems that haven't even been invented yet. And this isn't even a fluke for mathematicians. We have a good track record. Fancy hat-wearing man Hilbert? Look at this beautiful Hilbert curve. He just wanted to fill space with some curve. We're all looking for ways to fill some time right now. He invented that more than 100 years ago, and now it's the way that internet routers ping to each other. Imaginary numbers, invented in the 16th century. There was a problem that mathematicians couldn't solve and they just said, well, imagine if we could solve it, let's invent a number that would do that. How could that possibly have any bearing on the real world? It's just made up. But people use it in electrical, nuclear, and aerospace engineering. This bad boy here, it's a Penrose tiling, an aperiodic tiling. It's an open question up until the 60s. Could it be done with just 2 tiles? The answer, yes. Well done, mathematicians. Golf clap. In 2013, the Nobel Prize for Chemistry was awarded for discovering that the atomic structure of aluminium alloy atoms is a Penrose tiling. We don't have everything figured out though. Knot theory, we don't know a lot about knots. One of the open questions that we have that you could be working on right now, where should you snip a knot so that it untangles? Interesting question. Matt Parker points out, just look at the shape of bacterial DNA. Imagine if we could figure out the best way to snip them so that they were just rendered useless. The more people we have doing maths, the more amazing, weird discoveries we could have, and who knows how they might be used. I just love maths.